Okay, maths fans, back again with some more Maths Watch help, this time for Year 10 assignment on circle theorems, question 51. This is also available on in clip 183 as one of the later questions in the harder section, I think. But anyway, this is where it is. Okay, as I've always said with these circle theorem questions, you need to learn the circle theorems word for word. When you look at the stage of learning them, you really should have them written out and next to you, written down on a piece of paper so that you can refer to them. And you know, the more you come back to these, the more they'll sink in and they'll become automatic for you. Okay, again, the second thing to recognise here is that you've got to read the questions very, very carefully, because every bit of information is going to help you think of a theorem. So straight away, A, C, D are on points of a circle of radius 4 centimetres, centre O. We're going to need that 4 centimetres, maybe. B, A and B, C are tangents. Right, tangents, great. Tangent to a circle, what do we know? Angle between a tangent and a radius is 90 degrees. Bang, that's one of the circle theorems straight away. Alternate segment theorem involves a tangent. Doesn't look like there's an alternate segment on this one. And what's the other one? Oh yeah, the angle, tangents from an external point to a circumference are equal in length. So in other words, AB is equal to ABC. So that's important, isn't it? Okay, so I already know that before I've even started. So let's have a look at what the question is. Work out the length of arc ADC. ADC. Okay, so this is slightly different, isn't it, to anything we've had before. We are going to have to work out a length here. Now, how do we work out a length of an arc? Well, this comes back to some circle work we would have done, hopefully done earlier in the year. We're going to need to know the radius, and we're going to need to know the angle. In this case, this angle here, we're going to have to work out which determines the length of that arc. So it's all of this bit here we're after here, A, D, C, and I'm assuming they're talking about the major arc here. Okay, three significant figures. We'll come back to that. So we need the angle there. Let's call that angle X, just to make life a bit easier. Okay, so circle theorems to find that angle. How do we find that angle? Well, straight away we're probably thinking, oh, well, if I know this angle, that's 360 minus 8. I can work that one out, can't I? So let's get into this then. We need to find out this angle here. Now these triangles look like they're the same, don't they? But we can never assume they're the same. So we have to actually show they're the same. You can't say, oh yeah, they look the same. I can do that, because they might look the same. They might be 0.1 degree out of an angle, these two angles, and then we've got a problem. So, can we prove that they're the same? What does proving two triangles the same? I mean, we're proving congruency. So there's a lot of crossover topics here. So I need to prove that OAB, triangle OAB is congruent to OBC. Okay, so now looking at it, already we know that AB is equal to BC. Okay, and that was because tangents from external point are equal in length. Okay, what else do we know? Oh, we know these two are the same. Look, use two marks this time to show different, because they're both radius, aren't they? So AO is equal to OC, and we're just going to put radius of a circle. They're both radius of a circle. So I'm looking for side, or side angle side, possibly. What's the other? Oh, angle between a tangent and a radius is 90 degrees. So we know that that one's there. So I can say that OA, so what have I got so far? Oh, I haven't written this down in congruency language, have I? So side, and now I've got two angles, haven't I? So I'm going to say that angle OAB is equal to OCB, which is equal to 90 degrees. And again, I must give the reason. Angle between tangent and radius equals 90 degrees. And that's my angle, isn't it? So I've got angle, I've basically got, have I got side, angle, side there? Well, I have, haven't I? Look, side, angle sandwiched in the middle, side, and the same on this. So what I can say is, therefore, triangle AOB is congruent, the three lines this time, being identical, triangle OCB. And I'm going to give my reason SAS. So yeah, quite an extended question here, because we haven't finished yet, but what is it allowing us to do? We now know that these angles here have to be the same, don't they? This one here and this one here has to be the same. So how do we work that out? Well, we now need to work out what, we know that's 90 degrees. How are we going to work out these angles here then? Well, if that's 4 centimetres, okay, we've got a, let's have a look, where are we now? We're going to get this angle from here. OB is 10 centimetres, it says. Okay, now, this might be a bit of a stretch now, as we may not have done trigonometry at this stage, but if you have, you can see in this triangle here, that OA would be the adjacent, and OB would be the hypotenuse. Okay, and the angle is in this triangle would be AOB. So from SOHCAHTOA, for those people that have done this, we've got adjacent and a hypotenuse. We're looking at the cosine ratio there. So if I put that in there, cosine of the angle, let's call it, this one here, let's call it y. Cosine y is adjacent over hypotenuse, is 4/10. And so y must be equal to the inverse cosine of 4/10. Okay, now we might need to go back to trigonometry a little bit there. So inverse cosine of 4/10, or 0.4, I'm getting as 66.4 degrees. Okay, so that's that. Okay, so if y is 66.4, this also must be 66.4 because we've got congruent triangles, which means this x must be equal to 360 minus 60.4, 66.4 minus 66.4. So let's write this down here. X is 360 minus 66.4 minus 66.4. I'm getting 227.15 degrees. Okay, so we've got x now, and we're trying to find this arc here. So arc length, arc ADC must be equal to 227.15 out of 360. That's the fraction of the circle that we've actually got there, times by the circumference of that circumference, which is pi times diameter. The diameter will be 8. So this is going to hopefully be my answer now. So divide by 360 times pi and times by 8. And I'm getting 15.858. which 3 significant figures is 15.9 centimetres. Okay, that is a quite a long, challenging question there. You need to know trigonometry, you need to know about congruence, and you need to be able to find the lengths of arcs as well. But have a good, see if it makes sense. It's possible. I've rounded somewhere along here, didn't I? 66.4. I perhaps should have worked with that to perhaps 2 or 3 decimal places there. It's possible that might be slightly out from what the as it gets marked, but that method is the correct method to get there. So I hope that helps, and I'll see you next time.